Okay, so when you're doing implicit differentiation, remember the whole idea, the whole thing that makes this implicit is that you have y's everywhere, and you can't just easily get y by itself. So what we do instead is we derive, and then we get dy over dx by itself. So remember that your first step here is just to take the derivative of both sides. Now, for the most part, you're doing derivative just like how we normally have, except what do you do when you take the derivative of a y term? You write your dy over dx after that. So in looking at this left side, I'm going to apply chain rule. The 2 is going to go to the front. The x squared plus y squared, the power would then become 1. Then I got to multiply to the inside. What's the derivative of the inside? 2x plus 2y. And since I took the derivative of a y term, I've got to write dy over dx. Okay, that was me taking the derivative of the inside. So that's the left. Now on the right, I can do a really simple algebra step that's going to make my life easier. What do you think that is? Yeah, just distribute the 12 and make that 12x squared minus 12y squared. So you may have the question, if not now, it'll come soon. How do you know to do that? When do you do it? When do you not do it? You do that when it helps you, and you don't do it when it doesn't help you. That's the easy answer. But here's the thing. If I had forgotten to do that, I could still do this problem. I may need to do one extra step or something. So don't sweat that. Don't worry about that too much, okay? So derivative of 12x squared, that's 24x. Derivative of negative 12y squared, that's minus 24y. And again, dy over dx. This is the stuff I want you to know. I want you to know how to do derivatives. I want you to know that dy over dx goes after that. A lot of the rest of this is all algebra. So remember that what we want to do is we want to get these by themselves on the left side. Now I have an issue right here. Okay, it's an algebra issue. I have this 2y being multiplied to dy over dx, and then I have something else that should be multiplied to that whole thing. So I want you to see something. I can't just subtract out 2x, and I can't just divide this, because that's going to make this term over here messier. So I'm going to do something algebraic to break this apart. I'm going to take this, and I'm going to distribute it here and here. We haven't seen this yet. This was new. This is why we're doing this on the second day. Not all of them are going to be really difficult, and once you've seen this, you'll know what to do next time. So I'm not going to actually multiply everything out. Watch what I do here. So I'm going to have 2 parentheses x squared plus y squared times 2x. That's distributing it to the first thing. Then plus, in essence, I'm breaking this apart, breaking this binomial right here apart. And I'm going to have 2x squared plus y squared, okay, this part, being multiplied to 2y dy over dx. And the right side, I'm just going to rewrite. So minus 24y. Okay, so you may be thinking, you didn't really do anything. You just made it more complicated. Well, look what happened now. Now I have this whole big term here in front of dy over dx, and I have it here. Before, it was like locked inside of a set of parentheses. You see that? It's kind of like if you were trying to, in a problem, if you had a 2 and you were doing like x plus 3, and you were trying to solve for x, you would have to distribute through that too, right? There are other ways to do it, but it would be more complicated. Like if you wanted to solve for x here, you would distribute, then you would subtract out the 3, then you would divide the 2. That's what I'm doing here. Okay, so if I want just those terms on the left, I'm going to rewrite it. The terms I've boxed in green, I'm going to write those on the left. That means I've got to add this term over. Some of you haven't done math since the last time I saw you on Thursday, and that's why this is hard for you. Because you blew off Friday, and then you didn't do anything this weekend. That's not everybody, but I'm saying if that was you, that's why what I'm doing right here makes no sense. If you're like, I've really been trying, keep at it, we'll get there. Okay, the other things need to stay on the right side. So 24x needs to stay on the right side. This part over here, that also needs to move over. So I'm going to subtract that. Some of you have another problem. You like to simplify too much. And it bothers you that I'm not simplifying as I'm going. You can if you want, but just make sure you don't make mistakes. Because it's unsimplified, it's fine, but wrong is wrong no matter if it's simplified or not. Okay, so remember we're trying to get dy over dx by itself, right? So I'm going to write it out here by itself. I'm going to see what do I have left, those two things, right? So 2 parentheses x squared plus y squared times 2y plus 24y. And then again, the right side, just rewrite it. And then the last step, if you can get this far, you can get to the end. Because what's the very last step? If you want to get dy over dx by itself, divide. So you have the right side. We're just going to rewrite it. It's messy, so it's a lot of writing. So be careful that you're not like copying it down wrong. And then divide by that. Just be thankful we don't have to use this for anything. We don't have to plug in anything, or that is your answer here. So that's messy. This is considerably messier, more difficult, more algebra than the ones that we did before. So they're not all this bad, but I wanted to go ahead and just show you one. Okay, we're working our way up to it. Okay, so let's look at problem 2. This one is a lot cleaner, by the way. You see how all the terms are separate? Again, we're given this graph. We're not really using the graph very much, but I see it never says find dy over dx, but it does say find the equation of 3 different tangent lines, or 3 different lines that are tangent. When you see that word tangent, you need to be thinking, usually when she says tangent, she's talking about slope. And in this class, when you hear slope, you need to be thinking what? Derivative. I mean, if you had to sum up everything we've done this whole year in one word, it should be derivative, or maybe slope. But they're related in here. So, first thing we need to do is take the derivative. Okay, this is a much easier problem. This is like one of the first ones we did. So, everybody, what's the derivative of y to the 5th? 5y to the 4th dy over dx. Again, it didn't say to do this, but I know I need to answer the questions that come up. All right, what about derivative of minus y? Yeah, I'm going to go ahead and put a 1 in there, but you definitely don't have to. Just writing minus dy over dx, that would be totally fine. Okay, what about the next one? Minus x squared. What's that derivative? Minus 2x. We don't need a dy over dx. We only do that when we derive a y term. And then the equals what? 0. This is the place where most of you are going to make a mistake. And it makes me so sad when I'm grading. Alright? Because a lot of students just rewrite the number. But remember, you're taking derivative of everything. And the derivative of the number is 0. Okay, so I have 2 terms that have a dy over dx, so let's keep them where they are. And if you have been practicing this, you've probably started to notice little places where you can skip steps. I'm okay with that. Don't, you shouldn't be doing this all in your head. But if you practice this and get good, you start to see that the same thing happens on every problem. Like a lot of you could just write the answer here. If you're like, that's not me. Well, that doesn't have to be you. That's fine. So factor out dy over dx. And this is why I kind of wrote the -1, because I knew at some point I was going to factor, and it's a little bit easier when you see the 1 there. And again, if you can get here, you got to be able to know what the answer is. Just divide, okay? So dy over dx equals 2x over 5y to the 4th minus 1. So what does this mean in the picture? So I just said, when you hear derivative, dy over dx, you need to be thinking that that's the same as slope of the tangent line. Slope and derivative, derivative and slope. Okay? We are never going to leave that. Derivative and slope, slope and tangent. So I would just put a big M in front of that. That way we know that that's slope. So on A it says find the equation of 3 different lines that are tangent. Well, what do you need to write an equation of a line? You need a point and you need a slope. So I have an equation for slope and I have x equals 1. So I'm going to go up here and I'm going to find my y values. Okay, so we got to use the original, by the way. So y to the 5th minus y minus, if x is 1, 1 squared equals -1. Now, we could solve this by hand. You could also solve this in a calculator. How would you solve it in your calculator? I feel like we need to redo this. So get your calculators out.
That's cool.
Yeah. It's nice. So where's the solve button on your calculator? How do you get that? It's either F2 or F3. So just guess if you're not sure. So F2 solve. And I'm going to go ahead and use y. Y to the 5th minus y minus 1 squared, or you could just say, well, you know that's 1, equals -1, comma y. Remember how we always have to say which variable we're doing. If I had put an x in there, I would do comma x. Since I did y, it has to be comma y. And I get 3 different answers. Okay, so what I want you guys to see is that if you look on your graph, okay, when x equals 1, this is saying we have 3 different y values. That lines up to my picture. The 0.11, the 0.10, and the 0.1, -1. Okay? Y'all see that? This is where the picture, we didn't have to have it, but it confirmed what we found algebraically, or in this case with the calculator. Any questions on that before I move on? Because now we know the point. What am I going to do to find slope? Plug it into my dy over dx, right? Okay, so let's do this part by hand. So I'm going to actually go, here's 1, 1. I'm going to kind of separate my work into 3 sections. So if I'm trying to find my slope, okay, remember, here's my slope. So at the point 1, 1, when x is 1 and y is 1, 2 times 1 over 5 times 1 to the 4th minus 1. If you need to use your calculator, you can. You should be able to do this without. We should get 2 over 4, which is the same as 1/2. Okay, I'm just crunching the numbers at this point. 2 over 4, which is the same as 1/2. So my line becomes y minus 1 equals 1/2 x minus 1. And there's one of the lines. But there are 3, and that's good because I have 3 different y values. If you got this, if you're like, I totally understand everything you're doing, Ms. Brooks, I want you to try to find the other two. If you do not get this yet, I'm going to explain the second one again, and then everybody's going to try the third one on their own. So once you have the point, we plugged in x, we got 0 for the y, for one of the y's. I'm going to plug it in to my dy over dx. That's my slope, right? Because derivative and slope, they're linked together. So 2 times x, the x value is 1. The y value in this case is 0. So 5 times 0 to the 4th, that's 0 minus 1. This ends up being -2 when you crunch the numbers. So if my slope is -2 and my point is 1, 0, we get y minus 0 equals -2, x minus 1, and that's my answer for my equation of a line. Yes? No, you're fine.
Why is it the minus 0 not times 1?
Why did I have this here? Because this is like x1 and y1. And my point slope formula is y minus y1 equals mx minus x1. That's okay. It's easy. You push all this stuff in your brain, something's going to pop out, right? We just got to push it back in. So I want everybody to try that third one on their own. And if you've got that, I want you to read part B and see if you can have an idea. Always ask questions. That's how we learn. Okay, here's the answer to the third one. Check yours with mine. Does it make sense, by the way, that at this top point and at this bottom point, the slopes are the same? I mean, they look like they have the same slope. They look parallel. So that makes sense, right? What? Go ahead. A 2 on top. Oh, yeah. This 2. Thank you. I just wrote that down right. It's still 1/2 is the slope. Okay. Any questions before we move to part B? This is kind of a challenging problem. This is really stepping it up. The derivative wasn't too bad, but what we do with the derivative, this was kind of weird. Okay, let's look at part B. Find the coordinates of the points. This is implying that there's more than one answer. So your answer here should be x comma y, by the way. Okay? And maybe more than one x comma y, at which the tangent line of the curve is vertical. Okay, so when you hear tangent, you need to think slope, you need to think derivative, and for vertical slope, what does that mean? What is undefined? The slope is undefined, right? So dy over dx, that should equal a number over 0. What if this had been horizontal? 0 over a number. That's horizontal, 0. This is vertical, so we're saying a number divided by 0. So let me rewrite the... here's my dy over dx. And we're almost done here. This should equal a number over 0. So which part of my dy over dx should equal 0? The bottom. Okay? So 5y to the 4 minus 1 should equal 0. So we have to solve what y is. Again, we could do this by hand. It's not the hardest thing in the world, but I think we need to practice the calculator. So let's do that. Let's solve 5y to the 4th minus 1 equals 0, comma y. Now, if we had solved this by hand, it might not have looked exactly like this, by the way. And if you wanted to get a decimal for some reason, maybe your answer choices are decimals on multiple choice, you would just hit diamond enter, okay? So that's what I'm going to do. I'm going to write these as 0.66874. I'm going to go ahead and go since 8778, 874. And over here, my y value, I just have to hit to the right. It's the same thing, but negative, right? So y equals negative 0.66874. Well, that's not the whole point. I need the x value. Some of you are really starting to hate me, but that's okay. All right, now here's the beauty of it. Remember up here how we solved for, here we solved for y? We can do the same thing with solving for x. The bell's about to ring, but let's see if I can squeeze this in. So I'm going to solve again. This is a lot of calculator work in one day. I'm going to type in the original. Actually, I'm going to stop here, but because I don't want to, it's going to just be way too fast, okay? But here's what you would do. You would plug y back into the original, and you would solve for x. Y'all get that part of it? It'd be a little bit messy, but that's what we would do to figure out what x equals here and here. Okay? Messy numbers, though, on this.